Welcome to another video on solving Hackerrank problems, and today we'll be solving the lonely integer problem in Hackerrank. So what is this problem? Let's go on our whiteboard and first explain. Given a sum of arrays that we see on the screen right now, we need to find a number in this array that doesn't come, that only comes once. It is unique basically. So if you look at one, there are two ones. That's not the unique array. Here C2, there are two there, so that's also not unique array. If we want to talk about 3, then there's also 2, right? So 4 seems to be our answer, right? How do we identify this mathematically? That's the question in this particular problem, right? So there are actually two methods which we can solve this problem. Methods using which we can solve this problem. One is to use the XORing gate solution. Tilted. First method, XORing and the second method is basically some net sum method. Calling it net sum method, but it's not it's not called that. Just presume that for this video that. So we'll go over both of these methods and explain to you how both of these methods, right? So let me drag this particular thing on this side. We can actually, so when we talk about the XORing method, right? So for that, it's quite simple. What is XORing, right? So generally speaking, in that method, we use the XOR operator in code, which basically we apply that method to the current value of the result. And basically, what happens in that is that when we're XORing operator, we use XORing operator on something, which is this. This is the XORing, uh, you know, method or operator. When we use this on a number, what we mean is this basically, and this is equal to 0. And why is that? Basically, what we're doing in this case is, you know, uh, uh, any element appears twice, it cancels it itself out using this mechanism. So if we have in this case here 1 and 1, right? So 1 and 1 cancel it themselves out. 2 and 2 cancel themselves. 3 and 3 cancel themselves out, right? Leaving only 4. The 4 is the result of this operator, and that is the unique method, and that is our answer. So how do we implement that on code? We go back here. The solution is quite simple, basically. So first, we declare a result variable, which basically would contain our result value, which is going to be 0 at the start. And then we need to basically start a simple for loop in which we're going to apply all the XOR operator on all of the values to come to that net result. So for num in A, and we're just using a random iterator value here. We apply the XOR method, on the num itself with the using the num. Then we return the value of the result, right? That is basically how you use this operator. On this code here, you'll see we'll get the correct answer. Yeah, all of our test cases work properly. That's one way to solve this problem. what is the second way to solve this problem, right? What's our second method? Let me bring that, that particular array over again, because the second method requires the usage of mathematics, and we need to explain that math a little bit here, solving this problem. So let's bring this up, increase size. So the unique element is 4, right? So in this method, what we do is we first create a set. The set is a data type in Python that basically removes all duplicate elements. So it would basically remove all duplicates in our set itself. So it would remove all duplicate values from the array and create a set. That's the first thing we need to do, right? And you'll understand why. Then we sum the set, and we create a sum of the set, save that value. Then we sum the set, right? So that is the first few steps we need in this problem. To create a set, we create a set, we then duplicate that set, and then we take the sum of that set, right? So that's one way. That's one thing we do, right? Then we basically need to just get the sum of the entire array, right? That's the second thing we need to do. We need to get the sum of the entire array. So the array that's fed into this function, we just sum that array itself. So this is another two-step process. But when we implement this on code, it's going to seem very, very simple and easy, right? But we also need to make sure when we have this sum on the first set portion, we multiply this by 2. So we multiply this by, right? Or this for multiplication symbol. So multiply this value by 2, the sum. So how does that work? So if we have these arrays here, right? So if we do a simple set, it's going to be 1 plus 2 plus 3, that's going to be 6 plus 4, 10. So our sum of the set is 10, right? We have a sum of the set that's 10. The sum of the array is going to be, calculate that as well. Okay. Sum of the array is going to be 3, 6, 3, 6, 10, 13, 15, 16. The sum of the array is 16. The formula to find an answer is sum of the array into 2, which is 20. Let me just write out the sum of the set, which is basically the unique elements. Sum of the set into 2 minus, from this result, sum of the array. Sum of the array, right? So this mathematical figure supposedly gives us the result for the unique elements in this case, in this case, and this is basically something that you can test out on different array values. You'll see you'll always be able to find a unique value. This is the formula that we use, right? So XORing is basically the more practical method in the sense that it helps us find unique elements either way, right? But this is specific for these type of unique element calculation. So once we have this formula, let's try that. We have the sum of the set at 10, multiply that by 2, and then we deduct 16, right? That is our process. So let's do 20 minus 16, and this equals to, so according to this, our unique element should be 4 as well, right? And that is the unique element here. So how would this look like in code? So simply speaking, we don't need to do anything technical. So it's just a simple mathematical Then we write sum of set of A. We're first creating a set of A, we're using the set function, and then we're summing that value, right? Then we multiply this. I think I need like better thing is deduct the sum A itself. That should be the entire code. One line, one mathematical expression, two conversions, one conversion, two sums, and that should give us the proper answer. And see, all of our test cases are functional here as well. So that is how you solve the lonely integer problem on HackerRank. With that, we're going to wrap our video and we'll see you on the next video. Thank you.